Yeah, so answers 5 to infinity. 6 to infinity. Okay. 6 included. 6 included. Greater than 5. Greater than 5. How can this be 6? 5 not included. Okay, 5 not included. Fair enough. Yeah, let's start. So, yeah, first things first, I'm not given that excellent, right? So, if I just simplify solve this as we discussed in the previous class, till when I'm not multiplying with a negative sign, we go ahead with the normal way in which we are going ahead with equations. So, I transpose the values keeping the inequality same. So, I would write this as 5x minus 3x and is greater than, what do I get here? 90 minus 9 here. So eventually I get 2x is greater than 10, or in short we have x is greater than 5. Now please understand, if x is greater than 5 does not mean 6 to infinity. So it's 5 comma infinity, a circular bracket here, and it can go up to infinity altogether. Clear guys? So let's go to the next one please. Yeah, let's solve this. So we have two inequalities here separated by a conjunction called and. Okay. Minus infinity. Okay. Minus infinity. And 3 not 3 not integer. Okay. Integers taken integers the next. So the conjunction that we are using is and here. Okay. So we are a little careful there. Yeah, so let's look at both the equations simultaneously. Okay, so I'm looking at 3x plus 19 is less than 25. So if I look at this equation, what do I get? I get 3x is less than 25 minus 19. Or we have x is, or 3x is less than 6. Or we have x is less than 2. So this is one equation or one inequality or one range that I get. Clear? Now do not forget the conjunction used here is and. So I'm going with conjunction uses and, that means I'm going with the sign called intersection, whatever range I get on the other side. Okay. So on the other side, what do I get here? So if I simplify this, I get 7x is less than 29 minus 8. 29 minus 8 would give me 21, or I would get x is less than 3. Yeah. So I have two equations or two ranges given to us. And we are looking at intersection. Intersection means we are looking at common elements. Clear? So I'm looking at common elements. Will I include 3? No, right? So if you observe, this would give me, let's say if I'm placing my 2 here. So the first equation would give me all the range from negative infinity to 2. Okay? And the second one would give me, so the complete part from, negative infinity to 3 here. So all I'm talking about is the common zone. If you observe the common zone between both of them is this zone only. Clear? So your answer for this question becomes minus infinity to 2 circular bracket and maybe you can have a square bracket also. Clear? Let's go to the next one, please. Yeah, let's solve this.
సార్ లెఫ్ట్ సైడ్ నుంచి ఎక్కువగా బ్లింకింగ్ వస్తుంది సార్.
లెఫ్ట్ సైడ్ నుంచా ఇప్పుడు సరిగ్గా ఉందా?
No, sorry. From the starting, it is like that only.
It's due to the fan, I guess. It's obstructing.
సో స్క్రీన్ విజిబుల్ గానే ఉంది సార్, కానీ బ్లింకింగ్ వస్తుంది అంతే సార్.
Yeah, answer please. That's it. Sure, everyone. So what am I looking at here? So if I look at this, let's quickly transpose values. So my 5x comes on to my left, becomes 8x, and this becomes 20 minus 4, that is 16. Or this would give me x is less than 2. Yeah. So and I'm going with intersection. I transpose these values here, so I get what 3x is greater than I get 9, or I get x is greater than. So after the previous class, coming down to this class, I think it's very clear now that there's nothing common that's working between both of them, right? So this range would be from minus infinity to 2. Let's say circular brackets and intersection. I'm going from 3 to infinity. So all I see is I don't see anything common, so therefore my answer becomes no value of x satisfies the inequality. Okay, so linear inequalities are very easy. These are like basic linear inequalities. Let's move to the next one, please. Yeah, now let's solve this. Slightly combining more than one. Once again. So if somebody was missed the previous class, let's start understanding this way. So whenever you have 2x, 2 plus x is greater than 5 minus 3x. Clear? Can I say and 5 minus 3x is greater than 8? We use the word and in between, right? So the conjunction uses and. In a way, what you can do is you can take this as first part of the equation and solve. Clear? If I take this as my first part of the equation and solve, I would write 2 plus x is greater than 5 minus 3x. So what do I get from here? So 3x comes here, this would become 4x is greater than 3, or I get x is greater than 3 by 4. Yeah. So this is one range that we get from first part, and I repeat, we use the word and. Okay, and I get 5 minus 3x is greater than 8. Clear? So if I do this, then what do I get here? Or we can have, let's say, minus 3x is greater than 3. Clear? Or I get minus x is greater than 1. Go like equations. In the end, only we have to be careful if there is a negative sign with x. Now there's a negative sign with x, we need to make the value of x positive. So I'm multiplying the complete inequality with a negative sign. So the signs change and the inequality also changes. Okay. So this would now remain x. This would become -1, right? And now greater than would become less than. So this becomes x is less than -1. So I'm looking at the intersection part between both of them. It's very clear. If x is less than -1, which means my range here is going to be -infinity to -1. Clear? And intersection, if x is greater than 3/4, that means my range here becomes 3/4 to infinity. So it's very clear that again nothing is common between both of them, and therefore my answer becomes no value satisfies. Clear, guys? Right? Yeah, so simple. Yeah, the only thing is we need to understand these are nothing but linear equations only with an inequality system. Quick guys, all here now. Is that right? Online we have only 1, 2, 3, 4 answers. Okay, so we have 2 different answers, 2 to infinity, and we have 10 to infinity as one of the options. Is the answer? 2 to infinity. Okay. Siddharth, not it. Simple. Yes, you break. I repeat, break. If I am given this, let's say you ask this question to yourself. If I tell you, I give something like this case. Whenever you have a doubt, how do you read this in equation? X is greater than -4. Continue. No, I repeat, x is greater than -4 dash and x is less than 5. Or in a way, see, if you take them separately, guys, we take x is greater than -4. Okay, so if you go with x is greater than -4, so you understand now number 9, what are we talking about? All the values to the right of -4 will satisfy. Okay, till positive infinity. Now, if you take x is less than 5 as the second part, this is actually derived here. And you have remembered as a shortcut. Right? So if I take x is less than 5, I'm talking about, let's say, all the values to the left of 5 till positive infinity, till negative infinity. But we all know whenever we are given this inequality or this range, all we consider is all the numbers from -4 to 5. Right? So if you observe, from -4 to 5 is nothing but the common numbers between both the inequalities. Clear? Common numbers is nothing but I'm using the conjunction called and. See, after knowing basics of the equation, I should not have a trouble in answering the question on inequality rates. I'll tell you where the jackpot comes. Once you keep on moving forward, I'll show you one of the ZAT questions. The first question was the a question in ZAT, and then we had one more question in IFT, and both were sitters after you attended these. It's just that the fear of inequality among students does not allow them to enter. According to me, if you know the meaning of this and you know how to solve equations, nothing should stop you from solving this. That should be in the back of your head. Inequalities is nothing but simple equations with range, either less than sign or greater. Clear? So see, algebra they play the mindset here. You need to understand that. For engineers or for people who know mathematics, it becomes easy. But please understand the psyche of a non-engineer or a person who does not like mathematics. The minute he sees inequality, he might run away from it. Right? So the example plays with the strengths of both, non-engineers and engineers also. Right? So please keep that in mind. So I take one by one. You can solve this verbally also. -1 comes here, becomes an 8. Clear? Less than minus 3x goes on to the right, that becomes a 4x. If 8 is less than 4x, then what do I get here, guys? I get 2 is less than x. Now I don't want x on the right hand side, I want x on the left hand side. If 2 is less than x, which means x is greater than 2. Clear? And now the conjunction that we use is and is nothing but intersection. So let's now look at these two inequalities here. So I take my x on the right hand side, so this becomes what here now? So less than equal to, I get 2x minus x. So this comes here, this becomes a minus 10. Clear? So minus 10 is less than or equal to x, which means x is greater than or equal to minus 10. Do not get confused here. Because look at this, minus 10 is also equal to x. This is what it means. Minus 10 is also equal to x. So therefore, it becomes x is greater than or equal to minus 10. And then I'm talking about the intersection of both of them. Now, what do I get? So if you observe now, by now it should be very clear. I need not put it on the number line. But if you want to be very sure, so from minus 10, including minus 10, this is my range. And x is greater than 2. So not including 2. This is going to be my range. So 2 is not included, okay? So 2 is not included. My range of this complete set becomes 2 to infinity, 2 not being included. And I'm reaching to it. Clear, guys, everyone?
Sir, no need to compare the first and third expressions.
Need not. That takes care of it. Don't worry about that. Okay.
Okay.
A very good application-based question. I don't remember, but it had come in some of the examples. A very strong application-based question. So we have 48, 48, 44, 48. What is the answer? We are stopping at 48. 48. Anybody else? Yeah. So the biggest thing that is, the biggest thing that you have is positive integers. That is the reason that you need to understand, because we discussed when the variable is in the denominator, can I cross multiply? Let's look at it. So I'm looking at this as, so I have 1 by 2 is less than n divided by n plus 1. Okay. Now, can I cross multiply? In the previous class, we discussed that we cannot cross multiply, but why are we not able to cross multiply? Because the magnitude of n was not given in the previous question. If I am not sure the denominator is positive or negative, I cannot cross multiply. Clear? But here, I am clearly told that I want the positive integers that n can take. Okay, which means n is positive. If n is positive, I know n plus 1 is also going to be positive. So if this value is positive, I know that I can cross multiply and it will have no effect on my calculation. So I can cross multiply and this becomes n plus 1 into 1. Does not make too much of a difference. At the same time, can I cross multiply 2 with n? Of course, yes, because 2 itself is a positive number. So when I cross multiply, the inequality remains as it is less than. Clear? Or in short, what do I get here? I get 1 is less than n, or I get the value of n is greater than 1. This is what I get in my calculation. Clear? So the minute you understand that n is a positive integer, this question becomes a normal question like the previous one. Okay. So now again I can look at these two values now. So you take n by n plus 1 is less than 99 divided by 101. Let's cross multiply. What do I get, guys? I get 101n is less than 99n plus 99. Clear? And if I come down with this, what do I get? I get 2n is less than 99, or I get the value of n is less than 49.5. And we know that the conjunction that we are using here is going to be and intersection, and I'm talking about intersection. So I want greater than 1, and I'm talking about positive integers, which means my values will start from 2. And I'm talking about less than 49.5, and I'm again talking about integers. That means including 2 and including 49. I want to count all my integers. Yeah. So from 2 to 49, how many integers are there? We know there are 48 integers, and that is going to be my answer. Clear? Sure. Can I proceed? Yeah. Let's solve a quadratic. Yeah. Let's solve a quadratic inequality. Let's take a minute. Try your method and explain you the shortcut of this. Once we understand the shortcut, it's going to be a cakewalk for all this. Just take a minute. I want you to understand how to calculate this. We need to know the mathematical approach also. Sometimes example is really well. And और क्यों होगा ये quadratic equation है हाँ quadratic equation का x greater than minus होगा हाँ ठीक है it will be greater than equal to 5 वैसे तो ठीक this because the more important point I'm trying to see is whether you guys are aware of the basic method of calculating the values of. How do I basically calculate this kind of range given? I mean, I'm not even talking about inequality or quadratic or whatever. Okay, now understand this here. So whenever I have, let's say, two roots, I have two zeros of the equation. What are the zeros of this equation here? Zeros of the equation are the point at which this becomes a zero, as well as the point at which this becomes a zero. Clear? So to start at the very basics, how did it become 5? So if I'm assuming that x minus 5 should become equal to 0, basics of algebra, clear? Then I get the value of x is equal to 5. That means that x is equal to 5, this part becomes 0. That's why it's called zeros of the equation. Okay? Assuming that we are very new to algebra. Right? Now, I'm talking about x plus 2 is greater than or equal to 0, but I want the 0 of this point. So if I take x plus 2 is equal to 0, then the 0 of this point becomes that if x is equal to minus 2, this becomes 0. So I have two zeros of the range or inequation given. Okay? So let me now move forward. Yeah. So how do I solve this? Let's have it on a number line. Okay? So on a number line, all I would do is I would plot both the zeros of my number line. Okay. So this is a basic method which will help us in almost all the topics going forward in algebra. Okay. So two zeros is dividing my number line into 3 ones. Yeah. Now the logic is quite simple. I'm dividing into 3 points or 3 parts. So part number 1. My part number 2 would be, the range from minus 2 to 5. And I'm talking about my third range given to me is from 5 to infinity. Now the logic is quite simple, guys. If I just take one of the nodes here, if I say x minus 5, and I plot this on a number line, it's a very commonsensical point. Can I say for any value greater than 5, this node is positive? Quick responses online, guys. Yes, no, yes, please. Yeah, great. So any node to the right of the 0, this node is always positive. I repeat, to the right, this node is positive. To the left, I know that this node becomes negative. You have a doubt, take any number. To the left of this is, I know I can have 4. If I replace 4, 4 minus 5 will make it minus 1. The best part is 0 is a lovely number we have in our range. 0 minus 5 is also minus 5. So remember always, to the left of the 0, this becomes negative. To the right of the 0, this will become positive. It will become exactly equal to 0 when x is equal to 5. Is this point clear with all of us? Right? Now, this is the basic that I'll be using to calculate this. Okay. So we have two nodal points. Now tell me, guys, in zone 3, and my advice will be when you see positive, no, include zeros. What do I mean by that? So my one zone will be from 5 to positive infinity. From 5. So from 5 to positive infinity, this is either 0 or positive, because I'm to the right of this nodal point. So one nodal point is positive. You can also assume equal to 0, no problem. Okay. Now, to the right side of 5, can I say is as good as to the right side of this node also? Because this is minus 2. Huh? So if I'm in this range, I'm still towards the positive side, which means x plus 2, you take any value from here, will always be positive. Positive into positive is always going to give me a positive value or equal to 0 also. Because I have included 5 also as a point. Does this point clear, guys, with all of us? Online students, quick responses. Great. Clear? Right? So, which means, and the inequality that is asked me to be proven is greater than or equal to 0. So, can I say for this range, this inequality is true? Right? So, 1 is perfectly true. This is going to be my range. So, I get 5, infinity, and I have to include 5. Do not forget. Include 5 is equal to 0. If you make it equal to 5, you will have it as 0 as well satisfied. Here, this is a mathematical way. I'll tell you the shortcut. Next point. Within this range, now it's very easy. Okay? Within this range, I am to the left of 5. If I am to the left of 5, that means x minus 5 will be negative. Here, I am to the right of minus 2, make it equal to 0. Or let's not include minus 2. Hold. Let's not include minus 2. So to the right of minus 2, I think It will always be positive and not equal to 0. So positive into negative this is going to give me negative value. But the question is asking us to find greater than or equal to 0. Which means this range will not give us our required answer. Which means any number in that range will not give me my required answer. Okay? Mathematically, this is a very strong process. Whenever you are confused, apply this. Partial problem maybe. There's nothing more. You just see plus minus, that is all. Clear? So just understand it conceptually, then we will know the shortcuts. Okay? Now, tell me what will happen including minus 2 till infinity. Including minus 2, this will become 0 or this will become negative. Right? Equal to 0, I think include now. Okay? So either 0 or negative. And to the left of minus 2 is equally good as to the left of minus 5, which is again negative here. Negative into negative gives me positive. I am including minus 2 also, it means 0 is also satisfying. Which means this is a range which will always give me my answer. Clear guys? So what am I getting finally here? So minus infinity to minus 2, 2 being included is going to be my answer. This range satisfies as well as this range satisfies. So my final answer would be minus infinity to minus 2 union 5 to infinity should be your required answer. Here, this is a basic mathematical way for any student who does not want to apply graphs. Right? Now, did you learn in quadratic equation class how to form a quadratic graph? Yes, no, yes, no, yes, no. What are the components that I need to understand to just 1 second, right? 1 second, let me just take a look. Sorry, quadratic equation, how to make a quadratic graph? How to graph, how to plot quadratic equation? How to roots, lines. Yeah. So if you understand, guys, if you understand how to plot a quadratic equation on a graph, how do I plot a quadratic equation on a graph, guys? See, we know one thing here. Let me slightly digress because it's very important for us to have heuristic. Okay? So it's very simple that either your parabola would look something like this, or your parabola would look something like this, or your parabola, let's say, would look something like this. So one thing that is very clear, if you understand, is first we need to know whether the parabola is an upright parabola or an inverted parabola. Clear? Point number 1. How do we determine that? The sign of A. So if my quadratic equation is in the expression is in the form of ax square plus bx plus c. Clear? The sign of A will determine whether your parabola is inverted or upright. A greater than or equal to 0, we will have an upright parabola. Clear? So I do not know if you remember this or was this covered or not, but I'm sure this would have been covered first. A greater than 0, it is an upright parabola, and I go with A less than 0, I go with an inverted parabola. Clear? First things first. Second point, what is the second point? Anybody who can help me out with this? So I know that these are the roots of my quadratic equation. What do I mean by roots of the quadratic equation? The points at which the equation becomes equal to 0. So we know that if I have x plus 2 into x minus 5, so the second thing that I need to know is the roots of the equation. So I know that the roots of this equation are minus 2 comma 5. Clear? Third thing I need to know is where is the line cutting my y-axis. So line cutting my y-axis is called, the point at which the line cuts my y-axis is called
y-intercept.
Y-intercept. Right? So any point on this y-axis, can I say the value of x is equal to 0? So the third thing that you need to understand to plot a quadratic equation on a graph is you need to know the value of y-intercept. Clear, guys? So let's see what is the y-intercept. I repeat, y-intercept is nothing but if you make x is equal to 0 in the equation or expression, I always plot a graph of an expression only. I would say y is equal to x plus 2 into x minus 1. This is how I draw a quadratic equation on a graph. Okay, so we replace 0 I take plus 2 into the. If I make x is equal to 0, minus 5 into the plus 2 into minus 5 minus 10. So at y is equal to, so at point minus 10, we will have the parabola cutting. Okay, so how does this work out? Okay, minus 2 is one of the roots. Okay, guys. 5 is another root. Clear? And I know that at a point minus 10, this parabola is going to cut my y-axis. What is the magnitude of a? X into x will be x square. I think a is positive, so we will be having an upright parabola. Clear? So how does my graph look like? My graph would look something like this. It's coming up like this, cutting at minus 2, going, bending at y-intercept, goes up, goes up, goes up, goes up, goes up, goes up. Sorry, it might bend somewhere else also. I'm sorry. You'll have maximum minimum also, right? Yeah, but it's going to go something like this. Clear? But understand the point here. Y is equal to x plus 2 into x minus 5. Okay? And this line, can I say these corresponding values are the values of y? Yes, no, yes, no, yes, no. So understand, can I say for all the values of y greater than 5, so for all the values of x, these are the values of x and these are the values of y. So can I say for all the values of x greater than 5, the value of y is always positive? Yes, no, yes, no, yes, no. Online guys. Right? So always remember this parabola, okay? And I know that for all the values of x less than minus 2, the value of y is positive. Clear? So for a quadratic equation, which is really important for your examination, this graph should always be visualized on your mind. That's why I told you, not one range, you'll have two ranges. Greater than 0 is always a upright parabola. Upright parabola is always positive values of y or time and q. So these are the two ranges for positive values. Right? And I know that this range is the range for the value of x where the values of y are negative. Okay, guys, this is how we interpret a quadratic equation or on a graph. Okay, now comes down to the final chart. Not just for the quadratic, or this rule applies to higher equations also. Okay, so what is the shortcut here? I plot the zeros on a number line. Okay, let's say I have a 0 called 5, I have a 0 called minus 2. Remember the shortcut, it's always helpful. Doesn't matter how many zeros are there. Plot them on a graph. It divides into different regions, not bothered. So first region, second region, third region. I repeat, from your right hand side corner, because you also write like this on a notes, right? So when you're writing on, so it's your right hand side corner. So I repeat, I'm assuming I'm sitting like you. So your right hand side corner is this. Clear? So from your right hand side corner, start writing positive, negative, and alternate regions low, positive, negative, positive, negative, positive, negative. It doesn't matter how many roots are. Clear? Right? So remember, for all the zones or regions where you wrote positive, this inequality will be greater than 0. Clear? For all the zones where you wrote negative, this inequality will be less than 0. Clear? So suppose I change this question now. The answer for this question is minus infinity to minus 2. Okay, union 5 to infinity. Now let me change this question. What if I ask you this question? Give me the answer for x plus 2 into x minus 5 less than 0. I repeat, negative equal only, you can negative number. Look at the inequality less than 0. It's not less than equal to, it's only less than 0. Okay, so therefore, this complete zone is the zone in which I will get the value of x less than 0, not including the ends, because the inequality is less than. Okay, so here my answer becomes -2 to 5, both ends must be circular brackets also. Let me change it. Suppose I give you x plus 2 into x minus 5 less than or equal to 0. Only thing that changes is equal to 0 kada. So at x is equal to 5, this will be equal to 0. At x is equal to 2, this will be equal to 0. Right? So therefore, my zone here becomes -2 to 5 and both will be square brackets. This is how your answers keep on changing. Clear? Can I proceed? Online guys? Quick responses. Yeah, perfect. Can we solve this please? Slightly twisted. Very easy question. After it's twisted. Anybody with the answer? Not even one so far. Quick. We just need to understand how to solve these equations. Something. Okay. 0 to 5. 5 by 2. Now, okay, simple. It just sounds a little complicated. Let's see this. So I can take an x common first of all here. Let me look at it from a student who has a phobia towards mathematics. Okay. So I can forget this part here. As I'm telling you, till when you don't have a negative sign, right? I'm not supposed to be worried about inequalities. First things first is a request to all of you. Here. Second, a cubic equation. I'm sure we have seen polynomials in standard 8, 9, 10. It's nothing but how to factorize a polynomial. Here's standard 10 syllabus. Okay. So how do I factorize a polynomial? I'm just talking about. So if I'm given just this value, okay, 6x cube plus x square minus 40x. I'm excluding the inequality. So I see that x is common across. So as a student, I'll just do this. I'll take x common, I get 6x square plus x minus 40. Now what do I see here? I see this as a quadratic equation. So can I solve a quadratic equation? Yes. Let's try to simplify. What do I get here? 6 into 40 is how much? 240. So when I two such numbers whose product is equal to minus 240 and whose sum is equal to plus 5. So what are those two numbers? 15 into 16. If you have a problem, you can start doing this. So let's say 240 here. But either you can go ahead on these lines, 1 into something, or you can start dividing. This is 2 into 120, and then I get 2 into 60, and then I get 2 into 30, and then I get 2 into 15. If you are good at numbers, you could have stopped here only. 16 and 15. If you are not good at numbers, all you can do is you can also start Directly putting in the formula minus b plus or minus b square minus 4ac by 2a, because b square is very simple. Clear? Right? And please remember, guys, the minute in the examination this has gone to a cubic equation, I'm giving you simple mantras for cat. Tell yourself this part will not be complicated. This question has only one point, that you have to go to the first step called taking x comma and jump. Don't hesitate. Jump and start calculating this. If you're not getting this, put in the formula and get it out. Clear? So what do I get here? So 15 and 16, right? So let's go into this as 6x square. Let's say plus 16x, right? Let's say minus 15x, no? Oh, wait, plus 16 is right? So let's do minus 15x. Let's do plus 16 minus 4. Why did I do this? Because 16 and 40 multiples of 4 ho jayenge. Or 8 bhi ho jayenge. Okay? So this I can take this as 3 common. So I can take a 3x common. What do I get? I get 2x minus 5. Plus I can take an 8 common. This again becomes 2x minus 5. So in short, I was able to simplify this as x into 3x plus 8 into 2x minus 5. Now this is a standard 10 question that I'm expanding or I'm simplifying a polynomial or an expression altogether. Okay, algebraic expression. Clear guys? Now the minute I bring this is equal, greater than or equal to 0, this becomes, sorry, less than or equal to 0, this becomes a question of inequality. So what did we just now discuss the shortcut next? Write the zeros of this on the number line. So x, if it is x, the zero of this point is 0. Don't hesitate. What is the 0? 3x plus 8 is equal to 0. So minus 8 by 3. I told you guys how to calculate 0. Okay, just make it equal to 0. Okay, 2x minus 5 is equal to 0. And 2x is equal to 5 or x is equal to 5 by 2. I repeat, I'm a student. This is my notebook. From my right hand side corner, I will start writing positive, negative, positive, negative. This is a shortcut. In a way, your graph goes something like this. Okay, so it's coming like this, then it's going like this, and then it's coming like this. This is all your graph looks. And if you plot as a y-axis to them, you can see all these are positive values of y-axis, all these are negative values of y-axis. Clear? Now, what is the question asking you? Less than or equal to 0. So, negative zones. What are my negative zones? From 0 to 5 by 2. Okay. So, 0, 2.5. Now, is the inequality having equal to also? Yes. So, include both the ends. Clear? Union. Along with this, I have a few more guests. A few more guests that we have are, this is a complete negative zone. So from negative infinity to minus 8 by 3. So I'm going from negative infinity to minus 8 by 3. And again, equal to sign is given. So this is going to be my required answer. Right? So if I break the question down, this becomes a simple question. Guys, according to me, quadratic equations chapter, inequalities chapter, modulus chapter, you should not be leaving in the examination. Linear equations was always there with us, so linear. Now, along with linear equations, what do we also add? Integer solutions. That helps us in a lot of integer calculation areas, right? Then become a James Bond in quadratic. Inequalities, whatever you are discussing in the class, maybe a few more questions that you are solving extra back home. Modulus also will have in it. The minute you are done with these, you are only to the strong part of algebra and easy part of algebra. Because the minute we go beyond this, then comes the technical knowledge. Logarithms needs complete technical knowledge. Maximum minimum needs technical knowledge. Okay. And one more important topic that we also deal with is progressions and series. So if you're doing these 6 chapters of algebra, you're like super strong. Right? And the remaining areas will learn them in the class. But these 6 are connected. And nothing new school level. If you know how to expand this, I am teaching you how to bring inequality in place and get your required answer. So this is how you shortlist questions in the examination. I see any inequality question? Yes, I should solve in algebra. Maybe functions, let me try. That is how even I have in my mind when I solve. Logarithms, yes, because a certain number of formulas you get your answer. logarithmic inequality I pause. Because I have to try and see what is the final range coming out there. Clear? Right? So that is how you have to simplify and segregate your topics. So be very clear with this. Okay? Any doubts here?
Even if we have the notion of executing we do the same as
X will be negative with the income of negative sign multiplication. Suppose ilaga. Then what happens? You'll have to multiply one shot. What's the multiplication? This value will change into positive. And rest all remains. Okay, same algebra, nothing. Same algebra, you have to keep x positive always. Clear? Yeah, can we solve this now? I think this should happen first and then the next question. Okay. Human errors. Very easy question. 3 simple roots. Quick. Get the answer in 30 seconds. Let's learn all the required concepts. We are not learning anything because beyond level. A lot of institutes take pride, they make algebra very difficult because the engineers are there. You can always show your knowledge that has not. These are the only concepts which come in examination. Don't go beyond this. Right. So what are the roots here? The roots that I'm talking about are going to be -1, -7. So to the leftmost corner, I get a -7. Then I get a -1, and then I get a 1/2. Okay. So 3 notes. From my right hand side, I got a positive, I get a negative, I get a positive, and then I get a negative. And the question is asking me greater than 0, so positive. So 2 zones. So my answer becomes 1/2, comma, infinity, circular bracket, union, -7 to -1, circular bracket. Should be a required answer. Okay. Great. So few questions coming up in online zone also. Yeah. So yes, because now let me simplify this job for you guys. Okay. Tell me one thing here. Okay, what to solve? So take one more. It's okay. So solve both easy.
minus into minus we can find it.
Union 5 to infinity. Okay. So how will you solve this whole problem? Okay. Yeah, that's all mathematically. Okay. Let's eliminate that extra calculation. Now, mathematically, if I go, okay, mathematically, if I'm saying that a by b is greater than or equal to 0, doesn't matter. Either I want positive or 0 value. Okay. So one point is that okay, either I can have numerator positive, denominator also positive. So positive by positive gives me a positive value. Clear? So that involves a bit of complications also. We'll discuss that. Don't worry. Mathematically, we learn. Or we have numerator negative, denominator also negative. We will have positive value. Negative by negative term is positive. And then what we get? Or we can have numerator 0, denominator cannot be equal to 0. So denominator can be anything. Okay, denominator can be. Now instead of getting into these kind of cases, right? What I would always advise is, the simple shortcut is, eliminate the problem of this one. Can I do something such that my denominator is always positive? Yesterday, at the last class, we discussed. What value do I apply so that my denominator is always positive? Can I say if I make anything a perfect square, not a perfect square, if I make anything a square, right? Remember this tool helps a lot in algebra. Okay, square of a number is always greater than or equal to 0. Y is equal to x square graph, you always get a positive graph if you understand graph. Right? Because any input of x will always get x square as positive or equal to 0. Which means, can I say if I make my denominator a square, if I'm making my denominator a square, my denominator is always positive. Yes, no, yes, no, yes, no. If my denominator is always positive, my job is to play with the numerator only. Suppose I would have given this, or I would have given, let's say, x plus 3 divided by x minus 5, let's say, is less than 0. Okay. Now, all I'm trying to tell you is, if I'm making my denominator a perfect square, I'm sorry, if I'm making a denominator a square, it is always positive. Okay. Which means, in this case also denominator is positive. In this case also denominator is positive. Okay. This is either greater than or equal to 0. This is either less than or equal to 0. If denominator is always positive, so here what am I supposed to do? That this numerator has to be greater than 0. Because if I want this has to be positive. So numerator should be greater than 0. If I want this inequality to be true, can I say my numerator has to be negative? Yes, no, yes, no, yes, no. So in that case, what will I solve? I will solve x plus 3 should be less than 0 or something. So numerator, I am playing with numerator and inequality. Is this point clear with all this? On its rules. So if I need to make my denominator a perfect square, I'll show you both of them in the same slide, don't worry. So I need to make denominator a square. If I need to make denominator a square, what do I do? So I already have x minus 5 and I have x plus 3. So to make this as a square, I multiply my numerator and denominator with x minus 5. Becomes easier part. You know this. Next time don't waste it. Here, if denominator is a square, as I told you, all I have to now prove is x minus 5 into x plus 3 should be greater than or equal to 50. And we know how to calculate this. Only one cautionary note. Whenever you have a fraction, denominator cannot be equal to 0. In this, first, the minute you see this column, you have to tell into yourself first statement, x should never be equal to. Sometimes students come at this mistake. Sometimes. Okay. So the minute you see a fraction, denominator should not be equal to 0. These kind of questions are common in aptitude exams because you are writing under time pressure. You might know it. Right? College law or school law, we always commit these mistakes and got away because we had step marks. Right? In this exam, either you get a +3 or you get a -1 or you get a 0. Clear? So be very careful and knowingly give you these kind of graphs. Right? So what is my range here? Greater than or equal to 0. If you understand the graph, you have a -5, you have a +5, you have a -3. So if you understand the graph is going to be something like this. You should start visualizing the graph, which means away from the roots. Away from the roots, this will give you from 5 to infinity. No matter how equal to sign, x cannot be equal to 5. So there is a circular bracket here. No, not commit this mistake. Clear? Union away from -3, which means you have a minus infinity to -3. Yes, both of them can be included. Because numerator can be 0, denominator should not be equal to. Clear guys? Any doubts here? Quick responses? Online? Great. How do I do it less than? Let's just see, do we have the next question as less than? ठीक है, नहीं करेंगे. अब less than करने के लिए same करना पड़ेगा. I am writing x minus 5 into x plus 3 divided by x minus 5 whole square. ठीक है, is less than 0. Now we have made sure that denominator is always positive. कोई problem नहीं है. So the strategy here is I only play with my numerator, which means I am writing x minus 5 into x plus 3 should be less than or less than equal to. That's it. Okay. So what do I get from here? So I know that my answer will lie from -3 to 5, either a circular bracket depending on the sign or a square bracket depending on the. Yes, these are the two models when you have fractions and you have an inequality altogether. Here, let's move forward to the next one. Now, can you quickly give me the answer? Should not take more than 30 seconds. Denominator को positive करने का simple logic. -3 से 3 आ जाएगा. Oh, you have 1 minus x. Don't miss that. You don't have x minus 1 here. Yeah, let's see this. First, let's make denominator square. Denominator square कर ले तो क्या हो गया? अपना x plus 3 keep as it is here. Divided by x minus 5 है. ठीक है? To make denominator a perfect square, what do? I multiply my denominator with x minus 5 and I multiply my numerator with x minus 5. So I repeat, this now sounds like, what do I have? So I have x plus 3 into 1 minus x into x minus 5 should be greater than or equal to 0. Do not forget, first thing that you have to answer is x cannot be equal to 5. Do not forget that. First thing that you cannot forget is x cannot be equal to. Clear? All of us? Right? Up करते. But remember, x I told you should be a positive one. Here you have 1 minus x. That means you have to multiply with a minus sign. You multiply only once with a minus sign, only these will change. Okay? Which means you are multiplying. This remains as it is. This becomes x minus 1. Here, this becomes x minus 5. Less than? Less than equal or less than 0? Less than or less than equal? Equal to sure? Okay. Now can you get the answer? Yeah, now it's very easy. The only thing that you need to understand is that the value of x negative हो जाएगा तो अपन कम क्या? Clear? Can you proceed? So always remember, when you are multiplying with the minus sign, greater than becomes less than, greater than or equal to becomes less than or. What if we have also, please don't forget, you have to take care of this point. X is not equal to. Clear? Can we solve this quickly? Thirty seconds answer. Pick up hints from the class, guys. Pick up hints from the class. Why? Why? Somebody was saying something online?
Minus infinity to 2, sir.
Minus infinity to 2. Perfect. Correct answer. Who was that? I did not get who was speaking.
Sandeep, sir.
Sai Sandeep. Okay, cool. Now pick up the hints, guys. X minus 5 whole square. Doesn't matter whatever I input as the value of x. Can I say this is a perfect square? Yes, no, yes, no, yes, no. If this is a perfect square, can I say the output is always going to be greater than or equal to 0? Yes, no, yes, no, yes, no. So let's assume since the equal to 0 is not there, first things first, x is not equal to 5, we have to ensure. Yeah. Second thing, apart from that, anything that you input, you always get a positive value. If positive, if this is always a positive value, something in or positive value into something should be less than 0. So can I say I have to ensure that this value has to be negative? If this value has to be negative, simple logic, if x minus 2 is less than 0, that means x is less than 2. If x is less than 2, I am talking about minus infinity to 5 is not included. Yeah, so pick up instincts. So you can't say that x minus 5 into x minus 2 is less than 0. How can you say that? Square है ना? Clear? Same question. X minus 5 whole square. Yeah, there we go. Take let's solve this. Exactly right. I wanted to have to excitement screws us there. Quick, should be easy question after the previous one. Denominator is always greater than or equal to 0. A by B greater than or equal to 0. B is always positive. So I have to ensure that A is positive. If A is positive, I have to ensure that yeah, A is positive or greater than or equal to 0. So x minus 1 should be greater than or equal to 0. X is greater than or equal to 1. Only one catch. Whenever I see this, no matter I have a square, my first point is x should not be equal to 5. So you have an answer called 1 comma infinity, including both, and you have not equal to. Excluding the value 5 is the only catch point from this. Clear? Right, so in the online forum also I guess only one correct answer. Clear? Now, simple question. Just use your presence of mind. It's a very simple question. Just trying to confuse you. Pause, think what is happening. Get the right answer. How's it? Minus infinity to 5. 5 is not included. 5 not included. 2
2 also.
2 also not included, right? Equal to 0. It is equal to 0. No? Yeah, let's come down to this guys. X minus 2 whole square. Now, doesn't matter whatever is my numerator. Whenever I see a fraction, the best part is make denominator make denominator square. So this becomes x minus 2 whole square divided by x minus 5. So I have to ensure I'm multiplying with x minus 5 here and I'm multiplying with x minus 5 here. So eventually this becomes less than or equal to 0. So first things first, x cannot be equal to 5. Second point, now I have to solve x minus 5 into we have x minus 2 whole square is less than or equal to 0. Now x minus 2 is a whole square. If x minus 2 is a whole square, this value is always going to be positive. So if this value is always going to be positive, I have to only ensure that x minus 5 is less than or equal to 0. If x minus 5 is less than or equal to 0, I know that this is going to be minus infinity to 5 square bracket, but I have to ensure that x is not equal to 5, which means I'm going with circular. Clear? So yes, Komala, you're correct. Others here? None? Sure, can I proceed guys? Online students? Great. Let's move to cubic. Minus infinity to okay. Now, if you have picked up things from the previous questions, there's one simple way to do this. You can simplify this as x minus 5 whole square into x minus 5 into x plus 3 is greater than or equal to 0. Yeah, right? Now, we know this is always going to be a positive value. If this is going to be a positive value, you can ignore it. Clear? Which means I have to now ensure that this part of the equation is being held true. Okay? So for this to hold true, I plot the roots on my number line. I have a minus 3, I have a 5. From my right hand side, I write a positive value, I write a negative value, and I write a positive. Okay, and the inequality is greater than or equal to 0. So therefore, this zone holds true. So I'm taking from 5 to positive infinity, both included, no problem, no denominator. Right? And then this portion holds true. So union, I'm going with minus infinity to minus 3, again both included, and this becomes my answer.
Sir?
Yeah.
So the rightmost side should